So in this class, we are going to consider this part of our dynamics, which is important in your examinations as you are to consider your typical exam questions later on. So it is important for you to just understand the basics that you're going to use. And we are going to have all the classes considering the requirements of your dynamics because we already have the question papers. But just because most of you have been asking for introductions, so we are working on that so that at least we can understand the meaning of those question papers that we have been answering. And also, it is important that you join the membership so that you do not miss any of the other classes that you're going to have. And also, the revision of question papers, the requests. If you're having a request, that is the opportunity for you to join the membership so that we can work on those questions. So, guys, not wasting your time, we are going to quickly go through the Newton's three laws of motion as we understand the guy who is called, say, Isaac Newton, formulated famous laws of motion, all right, which was actually in 1686. Yeah, somewhere there. So, yeah, and we are still using these laws up to now. So, guys, we had these laws from our N3s, in fact, from N2. So, I'm not going to waste time. We understand the Newton's first law, which is based on the law of inertia. All right. That is the Newton's first law. The Newton's first law. So, this one is based on the law of what? This is actually the law of inertia. All right, so I'm just going to give in short, guys. There are so many definitions that we can actually be given, like the meaning of what it means, this law. So many things. So I'm just going to give this part. We know that a body will remain at rest or moving at a constant speed or velocity. All right, let's say this is the body. It can remain where it is, or it can be actually moving. But as it is moving at a constant velocity. The moment where you have the constant velocity, remember mathematically, it means our acceleration is 0 meters per square second. There is no acceleration. There is no increase in speed. There is no increase in velocity. If there is no change in velocity, guys, acceleration is zero. Because there's no change in what? Velocity there. So this is the condition that we are having, that an object can be as on its own as it is like this. All right? Meaning to say it is at rest, just not moving. Or it can be moving at a constant velocity. So a body can remain like that. It can remain in that state unless there is a certain force which is affected, unless unbalanced force is what acted upon it. If there is no unbalanced force, guys, these objects, they will remain as they are. This one will continue to move at constant speed or constant velocity. This one will remain at rest unless something has to push or to pull. Then there is what? There's an action there. There's a movement which is considered. So that is the condition that we're going to simply have. So here, I'm just going to write this, a body. I'm just going to write the short ones, guys, all right? There are so many um, presentations that you can have. So guys, me, I'm just going to write the short one. So a body will remain at rest or moving at constant velocity, constant velocity, where acceleration is what? 0 meters per square second. Unless, all right, unless this is not useless, but it's unless, all right, it is acted on by an unbalanced. So it must be unbalanced force that is gonna affect. So this is actually the basic part that you're going to have on the first law. So there, know that once there is an unbalanced force, then we are going to notice a movement. Then we're going to consider the second law. All right, so the second law, which is the law of force and acceleration. So this one is the law of force and acceleration. It gives us the relationship between the force and the acceleration. So that's the law of what? Force and acceleration, which states that the force experienced by an object is proportional to its mass times acceleration it experiences. This is exactly your definition for force. If you just understand your definition for force, guys, force is what? Mass times acceleration. So that is force is the product of mass and what? Acceleration. That is the law. So you can just write it in short like that. Guys, there's so many ways of writing this, but I'm just going to write in short, all right? So the force in short, the force experienced by an object is proportional. So this one is proportional. All right, sorry for that. So it is proportional to its what? So like force is proportional to mass and acceleration. All right. So actually, it is proportional to the mass times that acceleration. That is mass and what? Acceleration that we have. So that is the condition that we have in that case. So that is proportional to its mass times the acceleration. Times the acceleration. So this is what we have, it experiences. So that is, we can just have this one in short like that. Force is equivalent to what? Mass times acceleration. So in actual sense, we are saying it is proportional to mass times acceleration. So it will be force is equal to a constant mass times what? Acceleration. That is the condition of your question. So if we take a condition now that we are considering a force of 1 Newton, a mass of 1 kilogram, an acceleration of 1 meters per square second, this K becomes 1. So at the end, we'll end up with the formula that the force is equivalent to what? Mass times acceleration. And also, still on our Newton's second law, which is on the acceleration, guys. Once acceleration is there and there is a force which is given, we can have different forces as a resultant, guys, that you have to consider. Going to talk about that, those typical diagrams on a horizontal plane, what can actually happen, the forces that can act on a horizontal plane due to this, because we are considering what? The force. So it is going to be an extended part later on. All right, on number 3, we consider, which is our third law, that is the law of action and reaction. The law of action and reaction. So guys, we know this. For every action that we consider, for every action, there is an equal and opposite what? Reaction. That is the case. For every action, there is an equal and opposite reaction. Opposite reaction. So meaning to say, if two bodies exert a force, right? Two bodies, they exert a force on one another. The forces are equal in magnitude, but opposite in direction. Okay? If two bodies, they exert force, they exert a certain force on one another. The forces are equal in magnitude, but opposite in direction. This is the case of the law of action and reaction. So we are going to consider these laws, guys. And like I said, it is important that you know this part as we consider the part there where we are talking about what force is equivalent to mass times acceleration. We are going to need this, guys. We are going to need this in our calculations. So I'm not going to waste much time, guys, on these laws. Like I said, basically, I want you to go through your N3 just to revise the basics that we had, and also go through the part of friction. Yeah, the part of friction is where the forces were being included in your N3 engineering science. So let's consider, guys, the calculations of the force. Calculating force, that is the total force required. The total force required, or the required force. All right. So the motion of an object, guys, is being affected by conditions like the forces that we are going to experience on an object. An object, once we just have an object, let's say we've got an object which is placed somewhere, it is going to experience a lot of forces. It is going to experience the gravitational force due to gravity. So we're going to have gravitational force. The object can be affected by the frictional force, as the object will be trying to move going this side. Will be having the other side being opposed by what? The frictional force. Or the resistance. That is the rolling what? Resistance that we'll be having. It will be affected. So it can be affected by those frictional force. It can be affected by inertia of the object, initially as it is. We said we can consider an object on its own state, that its own state, original state, which is the inertia of an object, can be considered again. The inertia of the object. So we need to consider these in calculation. So whenever you are given, guys, to calculate the total force required, it is simply going to be taken from the sum of forces. So the sum of all the given forces that are affecting an object will be equal to MA. Okay, what am I trying to say, guys? An object can be affected. Let's say we have got a condition of a horizontal plane. Let's say we've got a horizontal plane. We want to understand this issue of the forces that we have. We might be given something like this on a horizontal, guys, we know horizontal ground. All right. So on a horizontal ground, let's say this is what we have. We've got an object which is being taken, which is moving in this direction. All right. So our object is moving in that direction due to acceleration. Due to acceleration. This is what we have. So this we are going to have as the force being applied for this object to move this side. But as it is moving, definitely it is going to be affected, or it is going to be opposed in the other direction by what? The frictional force. On the other hand, it is going to be affected by the frictional force on the other end. Remember, guys, your frictional force from your N3, we're saying this is the product. If we want to calculate the frictional force, is the product of the coefficient of friction times your normal reaction. That is the condition. So we are saying a body here is having a certain mass accelerated this side. But as it is accelerating, it is being opposed. This one is opposing. So it is carrying what? A negative, because it's opposing. This one is going in the direction that we want. So it will be carrying a positive. So due to the acceleration, there is a force there. Remember, you have the mass of the object. Mass times acceleration gives us what? The force. Remember that. So we are saying the resultant force, now what we call the resultant force is the sum of forces, these ones. This is the resultant force. Whenever you're talking of what? The resultant force, the sum of the forces. So using this condition, guys, we are going to notice that our sum of forces is going to be what? This one, which is going to be what? Positive, which is going to the right side. It is the one that is being applied to our object. So the F applied, what is affecting, opposing this object? It is being opposed by the frictional force. So we are going to subtract our frictional force. If there is any other part that it can affect, guys, what is it that can affect? What is that we can affect? There's nothing that we have there. So it is going to be this minus the frictional force equal to what? To the F that is being applied, which is in this case, the total, sorry guys, here we said this is equal to MA. Sorry, this is supposed to be equal to MA. So this F is the one that we have here as the applied force, the total applied force due to the resistance, your frictional force. So whenever you are saying it's the resultant, you are combining everything, it must be equal to what? MA, mass times acceleration. In every case, this is when you are having what? Horizontal plane. So you also have to consider if you are on another type, when you are maybe having against an incline. So these are the conditions, guys, whenever you are going to the right, positive, all right? This is according to the movement of the object. I'm just giving a basic view. They can say maybe the object is moving this side. You do not oppose that case. If it is moving that way, that means your force is going to be that way. But in a basic view of your presentation, you put the applied force, the total applied force to the what? To the right. What is opposing? To the left in a normal basic view. So this is the condition. So we are going to consider questions there, but guys, this is your basic view there. I don't think we're going to need a lot of things to consider, just maybe questions as we are working with questions. Then we can have a condition where the object is moving against an incline. We can have a condition where it is moving against an incline. An incline, right? Where it is taken to a certain, it is taken between a certain angle and the horizontal. Remember, it was moving horizontally before. Now, between this horizontal line, it is taken at a certain angle. So there's an angle between. So the object, when it is of an incline like this, it depends with the condition, guys, that you're going to have. We are going to have extended part about this one, but it in a basic view, we can have, let's say, an object when it is going up. We can also have a condition when the object is going down. These are the conditions that can happen on an incline. The object can start from a certain point going up, or we can have an object starting from the top going down. All right. So let's say it's a condition of a movement. That's a movement up an incline. a movement up an incline when the object is moving up. So the object can start from the zero where it is starting from rest. From our N3, remember those linear motion. When an object is starting from rest, it means your initial velocity is what? 0 meters per second. It moves to a certain velocity where you are given the displacement, the distance there. You also be given time, the acceleration. Remember those linear motion, you're going to apply that part. And like I said, once a theta is included, revise your N3 friction, topic of friction. That is where this part is being involved. So this is our object. Let's say this, we've got our object here, which is going up. So when the object is going up, it means the total applied force will be this side, right? Where it is going, it is the movement up. What is going to affect here? Remember, guys, once we've got angle theta, we are going to be talking of what? The component parallel to the plane, because we are opposing this way. So what is parallel to the plane? Component parallel to the plane. So we are going to consider component parallel to the plane. What also opposes is what? The frictional force, guys. We also have the frictional force opposing there. So we have the parallel component and also the frictional force. So that is the condition, guys, that you're going to simply consider. Remember, we're going to have your normal reaction, guys, there on top. And this will be our mg, which is the weight, and perpendicular. This one, my diagram now is like this one is a straight line. We need just a 90 degrees somewhere there, guys. We just need a 90 degrees. So it's just going to be something like this, so that we have a 90 degrees there. All right, so do not mind my diagram, guys. What is important for you to take into consideration are these forces, these ones. Remember, we have talked about going up and down, going up and down. So when it is going up an incline, your total applied force, and what is affecting on the other hand is what? The frictional force and that parallel component. The gravity pulls against motion. Our F parallel, remember our F parallel, guys, like I said, this is our N3. It is equivalent to mg sine of what? Mg sine of theta, which is what? The weight. So it can be calculated. It can be determined from this. So now using this part, remember our question, guys, is on the total force. We just need to know what will be this total applied force at the end. From the sum of forces, everything that we have is equivalent to MA. This part is not going to change. So let's consider, as we are going up, originally we are going up, where this applied force is going, it's always a positive. Even if it was going this way, you take that way where it is going. All right? Like in this case, we're considering a horizontal part, just saying it is going to the right. If it was going to the left, you're going to take it where it is going, it is positive, the applied force. Where it is going, you take it as a positive. What is opposing is the one that you take as a negative. So in this case, since the applied force is facing up, meaning to say on its side, it's positive, always on its side, it's positive. Those others forces that are opposing your applied force are negatives. So these ones, they will carry negatives, the ones that are opposing. So meaning to say sum of forces, it's going to be what? F, which is positive. What is opposing these two, which is we're going to subtract the frictional force. We're going to subtract the parallel component. So this is equal to what? This is equal to MA. So remember your parallel component, guys, your formula. Where you need it, we're going to substitute that. That is the case. So if we need this F, which is our total applied force, therefore F, which is the total applied force, will be what? Total applied force. It will be equivalent to what? It will be equal to, we take these ones to the other side. So it is going to be MA plus We take the frictional force that side, it is going to be what? A positive. We take the parallel component to the other side, it will be what? A positive. So this is the condition that you'll be having at the end. This will be the condition that you'll be having at the end as you are considering what? The total applied force. It is a condition of what? The incline that you are working with. So when you are doing question papers, guys, we are just working on that condition. All these explanations, you need the basics. So like I said, if you go through your friction, N3, it can help. So this one, let us just call it a movement up and incline. We are still having this of against an incline, but this one was going up. So let's consider when it is going down. All right. Let's say the object is originally going down. Movement down and incline. Movement down and incline. The object originally on its own, where it is starting, it is starting from the top like this. And it is what? Going down. Originally, that is its case. At a certain angle, theta. So it means, guys, this is where your applied force is, your total applied force, for it to go down. So what is going to affect opposite to the other side here? What is going to affect on the other side? What are we going to have there? We are going to have the frictional force opposing. But as we know on our diagram, guys, the component parallel to the plane, this one, always it is going this way. So meaning to say this time it is together with the applied force. Remember, this is what we want. The applied force, the parallel component, it is now together on the same side with what? Applied force. So using the resultant, that the resultant is supposed to be equivalent to MA. Like I said, guys, wherever this F is your applied force, it is positive always. Whether it is going down, you take it as a positive. What opposes it is the one that carries a negative. On its side, it is positive. Is the parallel component this one opposing? No. It is moving in the same way. So it carries a positive also. It is moving in the same way as your applied force. So meaning to say our applied force plus the parallel component this time must be equal to what? Must be equal. We have to subtract this one. It is opposing. So you're going to subtract the parallel, the friction here, the frictional force, going to subtract it. Remember, what is opposing has to be removed. You have to subtract it. So this is equal to MA. That is what you're going to have. So therefore, the total applied force can be calculated by the change of subject. Take this to the other side. So it is going to be what? MA. You take the parallel component there, it is going to subtract. All right. You take the frictional force to the other side, it's going to what? It's going to add. These are the conditions that you are going to consider in your revisions. As long as you have this in mind, guys, you're not going to have any problems in answering of your questions. Then we are going to consider questions where we are going to use, where we are going to be using the work done, calculations of work done and power. So like I said, you're supposed to join membership, guys, so that you make sure you don't miss other calculations that you're going to have later on. So this is it. I want to have the questions now, but before this, I just want you to have a basic recap of your, remember when you have the linear motion, those equations of linear motion, they are going to play a big role in these calculations. They are going to play a big role. Our equations of linear motion, they are going to play a big role. All right. So remember those ones, guys, from your N3, and some of these ones you're given in the formula sheet. So our equations of linear motion, So guys, it is just a matter of, I don't know, memorizing these. So remember that V is equal to U plus AT, where V is the final velocity, U is the initial, A is the acceleration, T is the time. So I'm going to write these ones later on, do not worry. Also that S is equal to UT plus half AT squared. Also, we need S is equal to U plus V over 2 like this times the time. And also, V squared is equal to U squared plus 2AS. So these are the ones, guys, that you had from your linear motion, and also the conversions on this part. Some of you have been asking me, why is it that whenever you are given kilometers per hour, you divide by 3,6? It is because of, it is just like, guys, knowing that 1 minute, if you know that 1 minute is equal to 60 seconds, where did you know it from? Where exactly did you know it from? You were given as a basic unit to say whenever you are dealing with time, a minute compared to seconds, hours compared to minutes, the hour compared to the seconds, 3,600 seconds. It is a basic thing that you were given. Follow up like that. That is the condition of conversions. They are basic units. So even on the conversions of the speed, velocity, this one, it is a basic unit that you also ought to understand or to know, that 1 meter per second is equal to 3,6 kilometers per hour. It is also a basic unit. So it can be used for conversions. If I know that 1 meter per second is equal to, let's say I'm given 1 meter per second, I know that 1 meter per second is equal to 3,6 kilometers per hour. What about 180 kilometers per hour? Remember, same units on the same side. So what is it that I want on this side? I do not know. So it's just like a proportion, guys. Simple proportion. Remember, simple proportion, you cross multiply when it is a simple proportion. You want to calculate x, so you cross multiply. So it's x times 3,6. 3,6x is equal to 1 times 180, which is 180. So at the end, divide by 3,6, divide by 3,6. So this is what you're going to have, 180 over 3,6. So it is a continuous equation. It is a continuous thing, guys, that you're doing. Each and every calculation, you are doing this. So at the end, you see that whenever you're given kilometers per hour, simply divide by what? 3,6. Just like that. Divide by what? 3,6. Divide by 3,6, just like that. So these are going to help us. As we can see, there is a need whenever there is a calculation of force, mass times what? Acceleration. So as you can see, guys, there will be a need of this, because where are you going to get acceleration if you're not given it? You're going to either use this part, or use this part, or use this part where acceleration is, because you need to calculate that acceleration if you're not given. So it depends with the question. And if the acceleration is positive, a positive value for A, it means that's an acceleration. That's an acceleration that you have there. If your A is having a negative, guys, it means there it happened to have what? A deceleration. It is what? A deceleration there. So guys, I'm not going to waste time about these values. You know these ones, guys. Your V, which is your final what? Velocity. This is your initial, your starting point. Your initial. And also know these words at rest. When the object is at rest, it means the velocity there is at what? 0 meters per second. We do not know, is it final or is it initial? You might start at rest. You are starting at 0. you might finish at 0. It means your final velocity is what? Is 0. All right. S being your distance, displacement, your T is time, and that time is supposed to be in seconds. So manipulations can be done to change the subject. This is in your hands, guys. So this is what you're going to need. With this information, we can answer the first part of our dynamics, guys, using this part of our forces, just an extension of our Newton's laws. So using this part, we can just attempt 1 or 2 questions. Then, like I said, it is going to be a continuation. There is still another part that we need work calculations of work done and power. So we're going to see that part. So let us quickly consider our questions as we are having these. I just hope with time, guys, we're going to have these questions quickly done. Number 1, we are given that a car moving at, take note, answer properly, guys. A car is moving at, it is that is your initially it is moving at this speed. All right, that is your initial velocity. So we're going to take that part later on. But where is it having the movement? On a horizontal road. On a horizontal road. On a horizontal plane, just like a horizontal plane. If you are given a horizontal plane, guys, it is either we've got the applied force and what is opposing there. So let's see, according to our question, what is it that we are given? So we are just given our object, nothing much. We are not given like there's a force that is up. Guys, we're not even given that. So this is it, guys. Here we're not gonna even have a lot of things. Our question here is direct. So according to our information, it is horizontal road, remember? So we are given initially it is moving at this, that is your initial velocity, 90 kilometers per hour. Remember, divide by what? 3,6. All right, remember that. 1 meter per second, like I was explaining there, is equal to what? 3,6. So you simply have to what? Divide. Remember that conversion there. So there we are given what? 90. So it is 90 kilometers per hour here. So 90 over what? 3,6, just like that. So that is your condition of the question. So this part was going to give us 25, just like that. So that's 25 meters per second. The brakes are applied. You are driving, guys, you're driving a car. You apply the brakes. What is going to happen? The speed will reduce, isn't it? The speed will reduce. So when the brakes are being applied, the speed, it reduced until the car comes to rest. Once you are at rest, the velocity is what? Is 0. So our final velocity as the brakes were being applied, it was 0. It ended up, the car stopped. Instead of telling us that the car stopped, they are saying the car comes to rest. You see, they're trying to confuse you guys. To come to rest, that is to rest. That is at 0. You can start at rest. You can start at 0. This one, you started somewhere, but you ended at 0. That is the condition of our question here. You have to consider it properly. The distance of what? 60 meters after a distance of what? 60 meters. So that is 60 meters. The mass of the car is 900 kilograms. So for the mass of the car, which is 900 kilograms, calculate on A, the deceleration. As we can see, guys, the object is taken from a certain velocity until it is now at 0. If we are to consider those linear motion, the graphs of the velocity time graph, guys, it is like this. This is your velocity in meters per second. This is your time in seconds, remember. So the object started somewhere at 25 meters per second there. It started initially here. And the brakes are being applied, meaning to say it is going to reduce until it comes to rest. until it comes to this is the condition of what? Of our object. So it is going down. That's a deceleration. But like I said, as you are calculating, for you to see that also is a deceleration, you are going to have what? A negative answer. But that is the condition of a graph. You're going down. If you start from zero from the rest and you're going up like this, that's an acceleration, positive value. You're going up. So in this case, automatically, guys, this one is what? It's a deceleration. So that is it, guys. How can we calculate this? We are given what? We've got U, we've got V, we've got S. Which formula can we use, guys? We've got U, V, and S. Given U, V, and S. We're just going to pick from these ones. U, V, and what? And S. Which one? That has got U, V, and S and can give us A. All right. There we have got time, but we do not have time. This one, time. This one, time. Here, we do not have time. We have got V, U, and S. We need A. So this was going to be the best formula for you to choose. That's how you take these formulas. Take what you are given. This is what you are given. And this is what you are asked. Which formula has any of these and also has acceleration inside? The acceleration is there, but there is no T. We do not have T on the given information. There, we do not have T again. There, we do not have acceleration. And also, we do not have T. So this one was going to work because we are given V, we are given U, we are given S. What we need is what? Is A. So let's take that formula. V squared is equal to, so I'm just going to quickly have this one. V squared is equal to U squared plus 2AS. Let us make A the subject. That's going to take the U to the other side. It was going to be a negative. So it's V squared minus, if you take this, it becomes a negative. That's minus, which is equal to, this is positive 2AS. 2AS. It's a positive, this one. So we need to calculate A. What is affecting is 2 and S, which is a product. So you divide by what? By 2S both sides, by 2S both sides, simply cancel like this. That was going to give you the value of A, which is your acceleration, just like that. So this is the formula for acceleration. Substitute. You have this. That is why you chose this formula. It is because you have this. So now if you choose a certain formula, then you find out these variables are not there. It means, guys, you actually chose what? A wrong formula. But in this case, these variables must be there. V is what? That's a 0. So that's 0 squared minus, what is our U? 25. So that is 25 squared. Everything over what? 2 times S, which is our distance of 60 meters. With your calculator, I want you to simplify this properly. You are going to notice that you're going to have what? A negative value. Negative 5.208 in meters per square second. That is to show us we are having what? A deceleration, to have that negative answer. So our deceleration, in actual sense, if you're talking about the deceleration, we are saying our deceleration is what? 5.208 meters per square second. This is your deceleration, having a negative answer like this. So you can even leave it like that, it's fine. But it's just like, guys, you are saying, I have a profit of negative. A profit of a negative, it means what is that you have? You have a loss. Instead of you to say I have a profit of a negative, you can say I have a loss. So when you say deceleration, there is no need for you to write the negative. But if you say acceleration, it must carry a negative. That is to show that it is what? A deceleration that is just occurred. So that is it, guys. And from there, the question was further extending to the calculation of the braking force. Braking force. It is because of what? Here, the brakes are being applied. We have a deceleration. So the force there will be called braking force. It is because of what? The type of acceleration that is being used. It is negative. But the formula for force does not change, guys. All right. Remember, your force is supposed to be equivalent what? Mass times acceleration. But this is what? F braking. So the mass is already there. That is 900. The acceleration is that negative acceleration that we have here. It is a negative to show that is what? A deceleration. But when you are calculating, you do not use that. You just take the magnitude of the answer. So that's 5.208. Just take the magnitude. Don't consider the sign. So that was going to give us 4,687.2. This is the force. Remember, force is measured in what? In newtons. So you can even convert this to kilonewton, divide by 1,000, 4.687 in kilonewton. All right. So that is the case, guys, that you can have in this simplification. So you just need to work out as many questions as you can. Then the time on another part, which is C, the time taken to bring the car to rest, to bring this car to rest, to bring this car to the velocity of 0. What is the time? So we need to calculate the value of t. So there, guys, calculation of time, this and that does not even need acceleration. Those calculations, guys, they are based on your linear laws, those equations. So what is going to be our time? This time, guys, we are saying we have what? From here, from the u, this is what we have. We have got initial velocity, remember? We have got final velocity. We have got the distance. We also have the acceleration. Remember, we calculated the value of a here. So which formula can we use to calculate the time? You are going to see that even the first one was going to be best, guys. We have got V, U, and T. And A. We need to calculate T. This one was going to work, but look, guys, they've got complicated things there. We've got complicated things there. Just to calculate time, you end up with a quadratic equation because this is T squared. Just imagine. Also, this one was going to work. It's fine because we've got U and V. It's going to work. Here we do not have time. So this one was going to be best. And this one, number 1 and 2, you just choose the one that you want, guys, between number 1 and 3, I mean. All right. So as for me, I'm just going to use the first one. V is equal to U plus AT. So we want to calculate T. Let's make T the subject. Take U to this side. It is going to be what? A negative. V minus U is equal to AT. We need to find T. What is affecting our time? It's a product here of A. So we divide by that A. So that was going to give us the value of T. So our T was going to be V minus U over A, of which we've got these values, guys. Our V is there. Our U is there. Remember, V, our final velocity, that's 0 there, minus U, which is 25, over the acceleration. Acceleration is negative 5.208. You use the negative there on your calculations. But on calculation of the force, you take the magnitude. Force, guys, you take the magnitude there. All right, of that acceleration. That is the case. So that was going to give us the value of the time, guys, which was going to be 4.80000 and so on. So that's 4.8 seconds. Just like that. We have got our time according to this question. So as you can see, these linear equations, guys, they bring you back to N3. So it is just a combination, N3, N4, combination like that. So if you see this part, we are given that a man with a mass of 90 kilograms is in a lift. The man is in a lift. So it's also against what? This one is against gravity. When you're given this condition of a lift, it can be a condition that you are, because guys, you're being affected by the gravitational acceleration. So the force already, we have got the part of the weight, mass times what? Gravitational acceleration. Already it's there, this one, due to gravity. All right, due to gravity. So this one, I just need you to have the basic notes before you answer the question. Due to gravity, it's already there. So your movement now is going to depend to say, is it going up or down? your movement is going to depend. So we've got a condition for upward acceleration, where you are given a certain acceleration that you're going with up. So in that case, guys, you're going up. That is the case for acceleration, for upward acceleration. So at the end, remember, guys, our concept, due to gravity, we are going up. So the gravitational acceleration, this one, will be affecting. It will be affecting. It will be going down. So you'll be having F minus mg is equal to ma. So you take this to the other side. Your F will be equal to what? Ma plus mg at the end. So it's not like this one is carrying a positive. No, it was carrying a negative, but you took to the other side. You to carry what? A positive at the end. So this is what you're going to have as the applied force. So the applied force will be equal to mg plus ma due to acceleration. This one due to gravity. So we can even factor out the m, which is common. So it will be g plus a like that. All right. This is when you're going up. On a condition that there is a movement, it can be going down. For downward acceleration. For downward acceleration. The acceleration is there, but you are going down on that acceleration. It is moving down for a downward acceleration. So if it is a downward acceleration, guys, already this is the condition. Your applied force is always positive. All right. So your applied force will be F. Then your due to gravity, this one, due to gravity, guys, due to gravity is always going down. So it will be minus mg due to gravity is equal to. Now it cannot be equal to ma, guys, because it is for a downward acceleration. So the part of the acceleration will carry a negative. This one, it was upward. It was carrying a positive. Remember, it is the mg, which was this side with a negative. Then we took it to the other side to carry what? Positive. But originally, this part was what? Having a positive. This one will carry a negative because it is going downward. So meaning to say the applied force at the end will be equal to what? You take the negative mg to the other side, it is going to be a positive. So it is going to be mg plus, mg minus ma. This one is already carrying what? A negative. Mg is now positive. That is for downward. So we can even find this F by factoring out the m, which is common, just like that. So these are the conditions that you're going to have. This will be applied force. So using this information, guys, we're going to answer these two questions, A and B, that we're given here, where we are given that a man with a mass of 90 kilograms is in a lift. Remember, a lift is taking up, can take you down. A lift. So they are saying, calculate the force exerted by the man, which is the applied force, on the floor of the lift when it accelerates A downward at this acceleration. It is going down. It is not, there's a movement, guys, but the movement is going down. So we are given there, the acceleration is 0.4 meters per square second, but it's going downward. So it is a condition of this one for a downward acceleration. There is an acceleration there. It is there. It is there. But only that it is going down. So it will be negative. That part of MA will carry a negative. So guys, I'm not gonna take a lot of information. Let me quickly write my answers. So since it is for a downward, we are going to take this one for a downward, which you said F will be equal to mg minus ma. We can also factor it out like this one, guys. Let's just take this one. M into g minus a. So that's our mass. We have got the mass of the lift here is what? The man with a mass of 90. So we've got his mass because it is about the man here. G, so G depends with the textbook that you're using. So I'm just going to use the G for the question paper mostly. G on the constants you're given as 9,8 meters per square second. So I'm going to use G as what? 9,8 meters per square second in this calculation. So that is minus A, which is our acceleration. Do we have the acceleration? That is, we are having the downward acceleration of what? 0,4. So that was it, just like that. So that was going to give us our F for a downward acceleration as it is going down. This is for a downward acceleration. All right. So that is it, guys. That was going to give us 846 Newton, just like that. And let's consider another part upward. When it is going upward at 0,5 meters per square second, meaning to say we are going to consider this one for upward. So for upward, our F is equal to what? So as we saw, guys, at the end, we're going to end up with this. So it was mg plus ma. Let me just write m into g plus a. So this one is just a repetition. The m as it is, the g as it is, only that we are going to add our acceleration of, we are given another acceleration here of what? 0,5 at this acceleration, at an acceleration of what? 0,5 meters per square second. So you're going to use that one that we are given this time. So that is the only condition there. Quickly gonna have this as 927 Newton. So this is what you're going to have. So that is it, guys. Just make sure you do work as many questions as you can. Just make sure to go through your question papers that can actually help as you are working with more question papers. That is the best way to make sure that you are revising, guys. So I want you also to work with this type of a question. All right, this can be another type where we can be given something like this one. A truck is moving in a straight line 120 at, right? This is at your initial on a horizontal road, just like on a horizontal plane, just like the case that we had, guys. So applied force, then this one will be what? Opposing on the other way. So, but we are not given all that. We are just given that it is moving at, which is our initial velocity, 120 over 3,6. That was going to be what? All right, this one was going to be 33 point something to something, guys. 33,333 meters per second. All right, then we are also having, okay, this is horizontal. It is brought to rest, zero. From this, it is moving. So it started from a certain one velocity. Now at rest, 0 meters per second. Like I said, guys, at rest, that's at 0 there. Over what? 15 seconds. The time you are given as 15 seconds. The braking force of F braking. Remember how you calculated this F braking. So you are given this time as 20 kilonewton. So calculate the mass of the truck. What is going to be the mass in this case? Guys, we had a condition where this was calculated from the first question, I think. And I said this F braking is supposed to be what? Mass times what? Acceleration. But this A is the deceleration. This A, it is due to deceleration. Because the brakes were being applied. So there is what? A deceleration is going down. So we need that A in order for us to obtain the mass, because this one we have it. So we are going to need this. Well, we are given this. We are supposed to calculate what? We are supposed to calculate this one. All right? This is what you're supposed to calculate. Are you having A? You do not have A. So calculate A first from the information from your linear equations, guys, of this one. Which one is the best, guys? The first one. Remember, V is equal to U plus AT. This was going to be the best. We can calculate A from the acceleration. So let us make A the subject. Take this one to the other side. It was going to be V minus U is equal to AT divide by T. Remember, that's a product. So divide by T, both sides. You are going to have your acceleration as what? V. Final velocity, that's 0 minus U. Our U is what? This one. 33,333, like that. Over what? The time. What is our time? 15 seconds. So that was going to give us a negative value because the brakes were being applied. There's a deceleration there. So that's negative 2,22 meters per square second to show us that it's the deceleration. But in your calculations, you use what? The positive, the magnitude of it is the one that you want. So you're going to take that 2,22, use it here because we need what? Remember our question, we need the mass here. So let us find the mass. We're just gonna make M the subject, divide by A, divide by A. So the mass is equal to what? The braking force that you are given over what? The acceleration, which is the deceleration, this one, the deceleration. So what is our braking force? We're given this 20 kilonewton, 20 times 10 to the exponent of 3 over what? That is over A. We're going to take that as a positive, right? We need the magnitude of it there, which is 2,222, like that. So this is it. So guys, I want you to use these basics in answering of the questions that you're going to have later on, because this part, like I said, it is going to lead us to calculations of major questions and questions actually from question papers. This part, they are questions. They can give you the first part of this question. Then the second question can be on the calculation of the work done and power. Or the other question can be on those kinetic and potential energy. This part that we've just done here, it is important. Questions can be asked. So go through question papers where you see that there's a challenge applying this information. Let us communicate. That is the purpose of the comment section. And like I said, make sure that you join membership so that you do not miss any of the other classes that we are going to have from this one going up. Guys, there are so many classes, so many videos that need to come out. So I don't even know how are we going to do it. So that's why we're saying, guys, join membership so that things become easier for both sides.